I myself, Dr.V.Meenakshi, working as Associate Professor in the Department of Electrical and Electronics Engineering, Sathyabama Institute of Science and Technology, Chennai. So today we are going to see about the signal flow graph. What is meant by signal flow graph? What are the advantages of signal flow graph? By using signal flow graph, what we can find? All those things we are going to discuss in this session. So first we should know what is meant by signal flow graph. Signal flow graph is a pictorial representation of a system that graphically displays the signal transmission in it. So by using the signal flow graph, we can able to determine the transfer function of a control system. So there are so many various techniques are there for you to find the transfer function. There are various techniques are block diagram technique. Then by using the nodal representation also you can find the transfer function. But why we are going for signal flow graph? Means this is a very simple method compared to the previous methods. Block diagram technique and all, it is a very complex method and also it's a time consuming one. So only we are going for the signal flow graph. So we can find our transfer function by using Mason's-Kane formula. So before going to that, we should know what is meant by a transfer function. So transfer function will be usually defined as a output divided by input. So you have to take the Laplace transform of output divided by Laplace transform of input with zero initial condition. That is the definition for a transfer function. So here the transfer function can be represented as follows: G of s equal to C of s divided by R of s with zero initial condition. So in this case, C of s is nothing but output divided by R of s is nothing but it's an input. So output by input for any system is nothing but that is your transfer function. So now we can go for Mason's-Kane formula. The Mason's-Kane formula for overall gain of the system is given by T equal to 1 by del into summation of k into pk into del k. By using this formula, you can find the transfer function of a system. We can see the explanation for each and every term in the formula. T indicates you the transfer function of the system. Pk indicates you the forward path gain of kth forward path. K indicates you the number of forward path in the signal flow graph. Del equal to 1 minus sum of individual loop gains plus sum of gain products of all possible combination of two non-touching loops minus sum of gain product of all possible combination of three non-touching loops and plus it will be goes on based on your loops. Then del k equal to del for the path of the graph which is not touching kth forward path. So this is an explanation for the terms we are going to use in this Mason's-Kane formula. So you can understand much more better while you are taking some example, we can able to understand much more better. So we can go for the example. Find the overall transfer function of the system whose signal flow graph is shown in the figure. So this is an example we are going to take. In this first step, you are going to find the forward path gain. So in this problem, we are having two forward path. So how to find the forward path? So the forward path can be found by means of the arrow marks. The arrow marks indicates the signal flow. So if the arrow marks is pointing the forward direction, that indicates you the forward path. In this example, we are having two forward path. So we are going to take the value of k as 2. The first forward path starts from node 1, 2, 3, 4, 5, 6 and 7 and 8. This is your first forward path. So take this first forward path and calculate the gain of your first forward path. So calculate the gain means multiply all the gains in the first forward path. So the gain of first forward path P1 will be equal to G1, G2, G3, G4, G5. So this is a gain of your first forward path for this problem. So second forward path is nothing but 1, 2, 5, 6, 7 and 8 is your second forward path. So if you are looking over this forward path, you can see that arrow marks, all the arrow marks are pointing in the forward direction. If you are seeing both the diagram, you can see all the arrow marks are pointing in the forward direction. Whenever the arrow marks are pointing in the forward direction, that we will be considered as a forward path. So multiply the gain in the second forward path. So the gain of forward path 2 is nothing but P2 will be equal to G4, G5, G6. Multiply all the gains in the second forward path G4, G5, G6. So this is your first step in your signal flow graph. First step, you are going to find the forward path. The second step, individual loop gains. So you should know what is meant by a loop. Loop means the signal will be start at one node and it will end at the same node. Then that node we will be considered as a loop. So in this problem, we are having three individual loops we are having. This is one loop, 3 to 4 is one loop, then 3, 4, 5 is one loop, and third loop is 6 and 7 is one loop. If you are looking over this loop, you can see that the signal is starting from third node, it is going to fourth node, and once again it is returning back to third node. So this is a loop. Loop means the signal will be start at a point, start at one node, and it will be end at the same node. That we will be calling as a loop. So in this problem, we are having three individual loops. So these are the three loops. Find the loop gain of individual loop 1. So multiply the gains in this loop. So the gain we are having G2 and minus H1. So if you are multiplying this two thing, minus 2 G2 H1, this is equal to P11. We are naming this as P11. So the individual loop 1, we are going to name it as P11. Then take the loop 2. In the loop 2, multiply all the gains and the feedback. So we are going to name it as P21. In that we are having minus G2, G3 and H2. Multiply it. This is a loop gain of individual loop 2. Similarly, take loop 3. Multiply the gains in the loop 3. In the loop 3, we are having G5 and minus H3. So, loop gain of individual loop 3 is P31. That is equal to minus G5 into H3. So, multiply the gains in the each and every loop. In this problem, we are having three individual loops. This is your second step. Third step, we are going to find the gain product of two non-touching loops. So, here we are going to take two loops, 3, 4, 6 and 7. So, if you are seeing 3, 4, 6, 7 means you are taking two loops. In the two loops, the number is not repeated. That means these two loops are non-touching loops. So, 3, 4, 6 and 7. This is a first combination of two non-touching loops. So, for this first combination, you find the gain products. Gain product of first combination of two non-touching loops. So, multiply all the gains over there. So, the gains there are G2, G5, H1, H3. In H1 and H3 we are having minus sign. So, it will become a plus. So, G2, G5, H1 and H3 is a gain product of first combination of two non-touching loops. So, take two more loops. So, the second combination of two non-touching loops is 3, 4, 5, 6 and 7. If you are taking two loops, you have to see the number should not repeated. If the number is not repeated, then the two loops is considered as to be a non-touching loops. So, multiply the gain products of the two loops. So, the gain product of second combination of two non-touching loops are the gain G2, G3, G5, H2 and H3. So, multiply all the gains and feedbacks. That will be the gain product of second combination of two non-touching loops. So far we have studied three steps. First step is forward path gain. We got k value was 2 forward path we got. Second step is we have found out the individual loop gains. We got three individual loops. Third step is gain product of two non-touching loops. In that we got the two pairs of non-touching loops we got it. So, next step is gain product of three non-touching loops. But in this problem we are not having the three non-touching loops. If you are seeing three loops, all the numbers are repeated. So, we are not having any three non-touching loops in this problem. Next, we are going to calculate del and del k. The formula for del is 1 minus sum of individual loop gains plus sum of gain product of all possible combination of two non-touching loops minus sum of gain product of all possible combination of three non-touching loops. Based on the formula, we are going to substitute it. So, del equal to 1 minus P11 plus P21 plus P31. This P11 plus P21 plus P31 indicates you the individual loop gain. In this problem, we got three individual loop gains plus P12 plus P22. This P11 plus P22 indicates you the two non-touching loops. So, substitute those values here so that you will be getting the value of del. Del equal to 1 plus G2H1 plus G2G3H2 plus G5H3 plus G2G5H1H3 plus G2G3G5H2 and H3. This is your del. Next, you are going to find del 1 and del 2. So, del 1 equal to 1. That means you have to see the first forward path. In order to find del 1, take the first forward path. In this problem, we are having 3 individual loops, 3 and 4. This 3 and 4 is touching this forward path, so we can't consider this loop. Then 6 and 7, this is touching this forward path, we can't consider this one. Then 3, 4, 5. 3, 4, 5 is also in this forward path. So, all the loops are touching this forward path. So, we have to consider our del 1 value as 1. When all the loops are touching your forward path, you have to consider the value as 1. Suppose if the loops are not touching the forward path, you have to take the loop gain and you have to do. So, del 1 value will be equal to 1 by considering your first forward path. Next, we are going for del 2. So, del 2 means this is your second forward path. In this second forward path, you got 3 individual loops. Check the loops 3 and 4. 3 and 4 is not touching this forward path. The second forward path starts from 1, 2, 5, 6, 7, 8. This is your second forward path. So, you are having a loop as 3 and 4 is your individual loop. That 3 and 4 is not touching this forward path. So, you can consider that loop gain and you can find your del 2. So, for finding a del 2, you have to consider your second forward path. In this second forward path, the loop 3 and 4 is not touching this forward path. So, we have to consider that gain and we have to consider del 2. So, del 2 formula is 1 minus P11, that is 1 minus of G2 H1 will be equal to 1 plus G2 H1. This is a formula for del 2. Then finally, we are going for Mason's gain formula, T equal to 1 by del summation of k, Pk del k, that is equal to 1 by del P1 into del 1 plus P2 into del 2. Here P1 and P2 indicates your first forward path gain, P2 indicates your second forward path gain. Substitute all the values, we are getting our transfer function as G2, G4, G5 into G1, G3 plus G6 by G2 plus G6 H1 divided by 1 plus G2 H1 plus G2 G3 H2 plus G5 H3 plus G2 G5 H1 H3 plus G2 G3 G5 H2 and H3. By directly substituting in the formula, we are getting this transfer function for this signal flow graph. Thank you.